Gravity. The reason for the arrangement of the universe. Up until 1915, the generally accepted theory for it was Newton's law of universal gravitation. But after that, something changed. Or rather, everything changed. One single man came along and proposed to the world that gravity was property of four-dimensional spacetime, and called that theory of general relativity. In the next year, he followed up with his two theorized gravitational waves. They were indirectly proven in 1974, winning a Nobel Prize, but just last year, the LIGO team was able for the first time in human history to observe a gravitational wave. Now, of course, comes the important question. What is a gravitational wave? Well, put it in the shortest possible way, a gravitational wave is a ripple in spacetime that travels with the speed of light. Of course, this is not exactly self-explanatory, so let's divide it a little bit. The theory of general relativity defines gravity as the curvature of four-dimensional spacetime. Now, what would that mean? Spacetime is stretched like a blanket. If we put a mass on it, it will curve in order to support it. Of course, the theory is much more complicated, but we will need just that visualization in order to explain the gravitational waves. Now let's consider for a moment spacetime as a one-dimensional line. Again, if we put an object, it will curve. But in this case, we can see that if we move the object around, the whole spacetime has to move as well. What we can take from here is that with the moving of one object, the whole spacetime has to rearrange itself in order to support the object.
Well, let's combine the things we have until now. We have this change in spacetime that travels with a certain speed. This creates a fine line between where has the change happened and where it hasn't. What does it look like? Like a wavefront. And it looks like a wave. The passing of a wave is characterized by the consecutive stretching and shrinking of the spaces between particles in the plane perpendicular to the direction of the wave. But the stretching happens on two perpendicular lines. So if the waves come from you, the movement of those particles will look a lot like this. When the change of gravitational field arrives, it interferes with the fields of the other fundamental forces in such a way that it causes the particles to move in this shrinking and stretching manner, and so the matter too arranges around the new field.
Okay, but how are we sure that gravitational waves exist? Easy. The Laser Interferometer Gravitational Wave Observatory, LIGO. The basics of its structure. First, the laser shines toward the beam splitter. Second, the light is divided toward the two mirrors and comes back. Third, if there hasn't been a gravitational wave, the two light waves will cancel out because the thrust of one of them will align with the crest of the other. But if there has been a gravitational wave, the two lights will have traveled different distances because the arms would have been stretched differently, and so their light waves will not align. This means that the scientists will be able to study the interference measured by the detector, and so uncover the mysteries of the gravitational waves. And finally, why are they so important? Well, until now we have studied the universe only through electromagnetic waves, which has its limits. They cannot penetrate bodies, they cannot escape black holes. But the gravitational waves can. From them we can learn about the distant parts of the universe, we can learn about the insides of the objects. It is true, the amplitudes of most of them are too small for us to detect. While any object that moves in an asymmetrical way produces waves, meaning me, you, stars, planes, everything except like perfect spheres that rotate around their axis and like perfect explosions, most things are too far away or too small or have too small velocity for us to detect the amplitude of the wave. Luckily, not all events fall in this category, and on the 14th of September 2015, the LIGO team was able, for the first time in human history, hear the universe.